Okay, that's great. So do we have everyone?
Yes.
Okay, so welcome to our workshop of data sculptures. My name is Katja Ladina, and here's Eduard Heimann. So both of us are going to be with you for these 5 evenings. And well, thank you very much for the interest to our workshop. We really hope that it's not going to be some sort of training of kind of us showing you how to do things, but we really hope that it will be collaborative work where we will explore all these fun tools together and the kind of the capacities of AI. So, Елизавета, для тебя мы спасибо за то, что присоединилась, заинтересовалась нашим воркшопом. Мы очень хотим сделать, чтобы этот воркшоп не был просто каким-то тренингом, и мы хотели бы, чтобы все-таки это была такая совместная творческая работа, где мы как бы пригласим всех студентов участвовать, соучаствовать и быть вполне как бы активными участниками процесса. Эд, может быть, мы просто сделаем небольшую интродукцию, повторим как бы бриф. Maybe, Ed, if you can turn kind of your cool images on, and I can just quickly reintroduce the brief so we know what we are doing today. Then we'll introduce ourselves, and then we're very curious to meet you guys, and we will ask you to kind of say a few words about yourself, if that sounds all right. Yeah.
Yes. Okay.
Good. So let me just look quickly into the brief. Obviously, once I need it, I closed it all. What happened? Zoom. Okay, so I would say a quick intro. I don't know, I hope you don't have that many questions. I thought the brief was fairly clear, but I just quickly repeat that. So what we are planning to do, and we these 5 days we're planning to experiment with the new AI-based mapping technique, allowing us to kind of jump beyond the traditional snapshot perception of territories. Basically, we live and work in this world where we all operate in these kind of very static maps, and with all these amazing tools which are coming into the picture, it's an amazing opportunity to kind of to start finding new ways of visualization of the dynamic processes which are happening around us. So, and what we're planning to do, we're planning to transform a sequence of satellite maps, imagery into the intelligent device that will communicate these kind of dynamics which are happening in territories. And we will, like all these processes, like growth, urban growth, urban sprawl, evolution, deterioration of the landscape and natural ecology. So all this we'll try to kind of to experiment with this kind of dynamic. And so we'll use the neural networks to lay historic data and extract these hidden dynamics, and we're trying to visualize them in this kind of 3 or 4 dimensional forms. I don't know, Ed, maybe if you can just show some, share your images. If
yes, I can. I have a small presentation about visualization, and I show some pictures.
Okay, that's cool. So I just quickly will just maybe go through methodology and program, or you prefer to just jump in right now?
Okay, no, I think you can go through the methodology.
Mm-hmm. Okay, no problem. So, and basically, Елизавета, для тебя, я не знаю, насколько было как бы понятно из брифа, который мы опубликовали, но мы собираемся, собственно, заниматься с помощью с помощью AI мы попробуем найти какую-то новую технику, новую технологию картирования, которая позволит нам выйти за рамки вот этого традиционного восприятия карт как каких-то статических объектов, и мы попробуем найти вот какую-то новую технику, которая позволит нам работать с динамическими процессами, которые происходят в крупных масштабах, такие как, я не знаю, расползание городской среды, убывание городской среды, либо, допустим, какая-то трансформация и исчезновение каких-то ландшафтов. И, собственно, мы попробуем превратить вот эту мы будем работать со спутниковыми изображениями, попробуем вот эту последовательность карт, которую мы сможем загрузить, превратить в какое-то интеллектуальное устройство, которое будет, собственно, передавать эту динамику из изменяющихся ландшафтов. И мы используем нейронные сети, чтобы, собственно, создавать вот такие слои исторических данных и извлечь эту как бы скрытую динамику, этот механизм и каким-то образом трансформировать это в 3-4-мерные формы. Собственно, поэтому мы и назвали воркшоп архитектурные дата-скульптуры, потому что, собственно, мы хотели бы не только, чтобы результатом процесса была именно какая-то трехмерный красивый объект, но чтобы он тоже был каким-то определенным инструментом, с которым мы могли бы считывать данные, с которым мы могли бы работать. Okay, so quickly about methodology. So we are going to work with GAN, and Ed would explain better what that is. The way I understand it is a type of neural networks, basically, and we're going to work with territorial data that can form and animate sequence of continuous images. So, and then we will go to move to volumetric algorithms, which would allow us to transform this kind of dynamic we grasp using the neural network into these three-dimensional objects. So we planning to experiment with visualization of this dynamic process and experiment with the way we perceive dynamics and kind of, as I said, jump beyond just the static maps and static mapping. We called workshop 3 we called workshop data sculptures, but I still hope that altogether we will be able to create not just a data sculpture, but something like something which will become a tool where you can really scan and kind of use it in terms of generating data about the dynamic processes in the natural landscape or context of the city. So в принципе, немножко для Елизаветы, для себя несколько слов относительно методологии. То есть мы будем работать с GAN нейронными сетями, которые позволят нам, собственно, собирать эти отдельные последовательность изображений, и потом, собственно, когда мы получим вот эту иллюстрацию динамических процессов, мы попробуем это трансформировать в какой-то новый, новый трехмерный график, новую трехмерную репрезентацию найти для этих данных. И, собственно, да, эта геометрия будет, собственно, отражать вот это преобразование территории и позволит нам запечатлеть вот эту пространственную трансформацию. So that's pretty much it on methodology. If anyone have questions, I hope, I'm sure once Edward will show images and will explain, he will explain a little bit better about the kind of aims and of the workshop. But feel free to ask if something is unclear. No? Then I can, if you want, I can jump into the program.
I can share the schedule.
Mm-hmm. Okay, great. So basically, Елизавета, для вас, для тебя на русском языке, поэтому я буду пока только объяснять на английском. Я надеюсь, все более-менее понятно. So we structured the workshop in a way fairly clear, I hope. So the first evening tonight, it's introduction, and then obviously, as I said, we're looking forward for meeting you and you introducing yourself to us after our intro. And then regarding work, we are going to download and prepare data sets from Google Earth Engine. And as I said, we really hope that it's not going to be just a training, but it will be like collaborative work. So you are very welcome to so that's why we put it as a homework. So you're very welcome after try to find your own data sets and somehow find an interesting dynamic process you're particularly interested in. So in terms of exploration. So, but I mean, you don't have to, because we'll do quite a lot of things together. But if you would like to push it, let's say, beyond, obviously, feel free to experiment it with yourself. And that's why the next day, tomorrow, we will start with kind of reviewing and a small discussion. If any of you will bring kind of your own data sets and you'll have your own ideas, and even something like saying like, oh, I'm very interested in exploring this process, and how do you think I should proceed, and where will I find these data sets, and we'll try to help you in this sense. But then after the short discussion, we will move on to training GAN model. And I guess if you're willing to, in the end of the day, you can always test your data sets and train your model based on your own data sets. And so day 3 is kind of preparing the model images for 3D processing. Hopefully everything goes smoothly. So on day 3, we will have already data which we'll be able to export into the visualization and export it into these volumetric objects. We're going to use Monolith plugin in Grasshopper. And basically day 3, again, in terms of homework, if you're willing to do that, it's about testing exporting your model, but also what will be really interesting for all of us is kind of your ideas about visualization of this data. So if some of you decided to work with a particular process, with a particular dynamic process which is happening in a city or kind of natural environment, it will be interesting if that would need a particular way of visualization, and what are your ideas about it. And so, and I guess day 4, it will be, we will start with kind of reviewing the progress and discussion about, that will be the moment where we'll be happy to kind of share ideas about visualization and brainstorm about the data visualization and a brainstorm around it. And obviously, 4th day, it's mostly will be about post-production training, and Ed will show us how you can kind of nicely present it and all these tools you can use in order to present your data visualization in the end. And I guess if we will be able to put a kind of a small narrative, each of you, and on the day 5, we will just have a presentation, review and discussion of around the tools and around what worked out, what didn't work out, and etc. So that's pretty much it. Елизавета, я не знаю, все ли было понятно?
Да, спасибо. Поняла.
Okay, guys, any questions so far? Is that all good? Thumbs up. Laura shows thumbs up. That's good. Ed, would you like to start screen sharing and?
Yes, I'll show the small presentation about the data visualization and how we can see to the visualization of the data, and because most of the things which we can see in the media, that of the data visualization, it's about analytical data visualization, and we also do this one too. But actually, they're interesting to start from another point of view to data visualization, and I'll show small video. Yes, it's very old our project, where we can try to convert data visualization to something which can be feel more than the understandable as a values or as analytics, and how you can see it show the figure of the people that can have speech about some data, and during they have this speech, the data started to rise up on his surface, which was captured from the 3D camera, and during this process we tried to convert the data to the feeling, no more than this usual charts or something like this, and it's we made it as a group Matryoshka, and next steps in the data visualization was that we made a lot of other data visualization tools to produce different effects, and for this we have a little bit two different approach. And first of all, it's a phonological approach when we can make a visualization special for the some event and all of things which can be created inside the this visualization or for this visualization. We adjust to the idea of the and the vision of this data. And another approach which we made and explored, it's a universal approach when we tried to see all for all events which you can translate to data visualization as a universal object, and through this and to try to find try to find some features which we can convert to the some visualization which has special a special view, and in the для Елизаветы я повторю, что мы первое на видео, которое показывал, собственно, там вся основная была идея это создать визуализацию, которая не была просто похожа на какие-то стандартные чарты и даты визуализацию, а скорее ощущалось бы как нечто, которое... И для этого мы делали такое прирастание данных к человеку, к форме человека в процессе того, как он рассказывает, ведет какой-то диалог и рассказывает об исследовании. На втором слайде я показал, собственно, отличия двух типов визуализации, когда мы визуализируем что-то, то есть когда мы подбираем визуализацию под специфические особенности самих данных и самоявления, либо мы создаем некий универсальный движок, универсальную систему, которая позволяет визуализировать очень разнообразные данные. On the third slide, I show that we make we try to understand how we can visualize time-based data, big data, and it's a research about sentiments in Moscow, how people tweet about places, and of course this general idea that we can put dots into the map to and show the distribution of the sentiments through the map. A second idea that we can animate this but animation, it's a good good approach to show the dynamic of the data. But actually, problem of the animation is that we can see the 4D space in the same time, and for that we designed this type of the data when each place when we have a map, flat map, and we have a vertical axis that show the time, and if something grow up in this place, I mean some topics in this place which was during some period of time, and we can see there not just that is happen one or several times, but we can see there some blobs which can be generalized during all of the events which was happen, and we can see these blobs and see how which places more interesting for the people, and this approach help us to understand better the whole Moscow sentiments. Interesting questions that watch in that visualization, that we can always when we work with data and try to visualize it, we actually always it's always about interpretation. What it means that how you show the data, it's change the way how the people who see this visualization will be understand the data. And if you change, and if you manipulate with the visualization interpretation of the data, you can change the way you can extremely change the understanding and finding of analytics, for example, and we understand. And when we started to work with the data, we understood that we need to give people manipulate with data by themselves. I mean that, for example, in this project, you can see the data on the Barcelona. It's a tourist places where tourists go for frequently. And you can see the small peaks and blobs, and it's different layers of the generalization of the data. If small peaks happen near each other, we can convert it to the some big blob, and this can be regulated, adjusted by the user, and he tried, and during this process he explored the nature of the data and what's really happened in the Barcelona. Для этого, то, что, собственно, на первом слайде был, на этом слайде был слайд с Москвой, где мы показали, где мы исследовали, для того, чтобы исследовать сентименты в Москве, мы разработали интерфейс, где у нас на карте росли вот такие пузыри, и по вертикали было время. И, соответственно, можно было хорошо наблюдать во времени, как развивается то или иное событие. На этом слайде показан проект с Барселоны, где мы пытались разработать идею того, что мы должны давать пользователю манипулировать с визуализацией данных, чтобы менять его понимание. Потому что в любом случае, когда создается какая-то визуализация данных, в любом случае вы манипулируете восприятием информации, и без этого невозможно. И для того, чтобы быть максимально честными, мы самим даем возможность немного регулировать визуализацию так, чтобы что-то становилось более понятно и непонятно. And this approach we can see in this slide too, but we can actually additionally, we can see the connection between some places. And actually, this in this case, we can see the another approach when we make a mirror of the map, and we can show the different kind of the processes in the two sides of the map. Some process can be placed on the top of the map, and another events which we would like to compare with the first one, we can put on the downside of the map. Да, здесь, собственно, показано, что у нас здесь продолжение этого подхода, здесь только появляются еще дополнительные связи между местами. Здесь еще виден еще один процесс, когда мы как бы видим пока два противоположных события или какие-то явления показываем с двух сторон карты. Таким образом мы как бы расширяем пространство восприятия и возможность сравнивать некие события. Next slide, it's also about the approach which was created during our research of the specific data visualization with map and time, and we to make this we understood that we need to make a new we need to make a new technique for data visualization and new type of render, and for this we explore the technique which was used for the MRI to scan the body inside the body, and we use technique render technique and made a new our render engine, which allow us to render the data in location in time in one data visualization, like you can see in the right picture. And how we can see this is a really look like a visualization of the MRI, but this is a city data, and it's allow us to look at the data as a 3D objects. It's already like some sculpture, but it was it's a tool which was used by our analytics to understand some events or which happened in the cities, and it was a little bit hard to it for the hard I mean for the computer for the computer powers, but it was for us it was like a pivot in our understanding of the data visualization. And of course, it's to make this real, we create our database, which allow to save the data, save all of the data in the site of the 3D cube, which was to access that represents the space, and third axis is the time. And inside this group, we can combine all events like people moving or tweets or something like this. And it's a universal approach which give us a lot of power for creating analytical research. And the next things was about near to our it was close to our workshop. It's how we can create how we can use neural networks to create some physical or 2D or volumetric object which can be which can be which can be created during the usual process of generation of the architecture. And this is a project. This is one of the last my projects, Endless Skyscraper, which was generated by style gun during style gun images, and the pipeline which was which Katya is shown with the monolith and Rhino. And to create this kind of skyscraper, generated skyscraper, I used style gun 2 model. It's with was training on the architectural plans, and what you can see, this is the images was created by the style JAN model, style JN neural network. And how we can see, this is a continuous animated images which smoothly go through the process of the animation. And it's I use it for the generation of the plan of the this skyscraper, and it allows me to create something that can be created by the traditional approach of the architecture. What interesting for me that this approach allow me to create to think about the aesthetic things and understand how we can create the architecture and how this architecture can be look like. And I'll show this some videos which I created. Just a moment, I need to share the videos. Oh, just a moment. I'll show several videos which was created during process of the research and explore this technique with style GAN. But maybe you can see it smoothly. Sorry for this, and I just say several. I just show you other videos. And for this new shape of the architecture allow me to think about deeply inside the aesthetic. What's architecture is about, and how we understand and how we can understand the graphic of the architecture, how we can understand the shape of the architecture, and I think we can make something. We can, based on this approach, which I made for create this project, and we are going to cross is with a map and Google Earth Engine to create something absolutely new. It's our collective project, which can be can be like a architecture, and data sculpture, but it's show not just only the like architectural plans, but it's visualize can visualize the dynamic of the process of which happen in places. And they're interesting that when we can create training the neural network, they're interesting that we need to create to train the neural network. We need to combine database and give it to into the model, training model of the neural network, and you can see the distribution, some idea of the distribution. If you have a database which very dynamic, and inside this database we have a really distribution of the data, features of the some data. I mean, maybe all of images which we all images inside the database, if they will be very different from each other, there that allow the model to create images, outcome images with this distribution of the features. If all features, if our data set created by the data, like a static data, I mean, when you not have a dynamic inside, and maybe we can see the some map and during the several years we don't have any kind of dynamic, and all on these images is static. And if you train with this data, we model outcome of the model will be very static too. And this is interesting, and we can during this idea, I think we can find some features of the data which can be understandable by the human processes of the explorer. Да, мне кажется, я тут забыл договорить тогда по-русски, что мы для того, чтобы разработать 3D, чтобы иметь возможность визуализировать данные, картографические данные в новом времени, мы разработали инструмент визуализации, который основан на МРТ, подобным МРТ-снимкам. И для того, чтобы это работало корректно, мы все данные преобразовываем, сделали систему, которая преобразует все данные в такой пространственно-временной куб. И это позволяет нам работать с абсолютно разными данными и засовывать множество вроде как будто бы различных данных, но в один процесс визуализации. И потом я в конце, собственно, показал свой проект и визуализация с него, который я делал в качестве эксперимента с нейронной сетью StyleGAN 2, где бралась модель, научная на архитектурных планах, и она преобразовывалась собственно, в подобный бесконечный небоскреб, потому что он бесконечный, потому что он может быть генерирован бесконечно, и в то же время он собран как такая некая бесконечная петля. Вот. И подобную технику мы, собственно, и будем использовать на нашем воркшопе, когда мы будем генерировать тренировать с модель, но мы будем тренировать ее не на архитектурных планах, а будем тренировать ее на картах и преобразовать ее в объект.
Такой вот объект.
Да. Вот. И я рассказал последней моей идее, что идея в том, что когда вы собираете датасет, если он статичный, то есть если там почти ничего не меняется, то у вас и генерироваться будет изображение, которые были натренированы сетью, которая была натренирована этим датасетом, она будет очень статична, как, собственно, у нее будет распределение такое, что у вас будет все среднее и почти не будет отклонений. А если у вас будет как раз какие-то динамичные процессы, вы снимете с карты, то они сделают таким образом, что у вас и будет выдавать очень разнообразное изображение, сеть будет выдавать разнообразное изображение, и, в общем-то, из этого датасета будет зависеть, собственно, как вот именно насколько он динамичен сам внутри себя.
Ну, то есть в зависимости от того, сколько данных, за счет этого у нас получается более насыщенная модель.
Не только самих данных, а еще качество самих данных. В смысле, что если вы возьмете, условно говоря, какое-то место, которое почти никак не меняется, и вы снимете это за несколько лет, но при этом оно все равно никак не меняется, то, в общем-то, натренировав модель, она и будет выдавать очень похожую, почти не изменяющуюся, не анимируемую практически картинку. А если вы какое-то дадите изображение, которое очень сильно, карту, которая очень сильно изменяется в процессе во времени, то, соответственно, то есть она сама просто, то есть каждое изображение будет очень сильно отличаться друг от друга собранных в течение нескольких лет, то, соответственно, вы получите очень разнообразный датасет, и, соответственно, и то, что будет выдавать StyleGuide, то есть как бы модель натренированная на этих данных, она тоже будет выдавать очень разнообразные изображения. И это как раз можно будет увидеть вот эту вот скрытую динамику, можно будет увидеть ее.
Ну, то есть получается как количество данных, да, и сама суть вот этих данных.
Да.
Ага, спасибо.
Okay, this was my last slide. Maybe.
Maybe I just will add quickly, just a little summary. So we kind of forgot to introduce ourselves properly. So Eduard, he's a designer and he's a person who for many years, well, he's a founder of one of the founders of data visualization and data science company. And he works for many years with urban data and visualization of urban data. And that's why at the start we've been talking about the dynamic process in the cities or in the territory, and that's why we've been talking about these kind of new tools. And what he showed is one of the examples of those tools. And and me personally, I'm a person with kind of have an urban design and architectural background, but for many years I work and teach landscape architecture. So I work with landscapes. So I work with large scale processes. I work with urban ecologies. I work with natural ecologies, and etc. So when we've been thinking about the idea for the workshop for digital futures, we Ed showed me his project of his Endless Tower. And we thought, why won't we try together with you guys scale up this tool and try to model some dynamic processes which are happening in the landscape. So in this Endless Tower, this is just a kind of a list of plans, and neural network is basically learning and trained on a data set of plan of the building. But we thought, why wouldn't we just pick some sort of dynamic process in the landscape where landscape or some sort of territory, even urban territory, kind of transforms, and we'll try to train a neural network on that, based on that, and which kind of visualization we can get out of it, and can it become just a sculpture, or can it become some sort of analytical instrument, which Eduard showed at the start. Елизавета just по-русски просто немножко суммировать. Эдуард работает с визуализацией данных очень много лет. Да. Ну, отлично.
Я была на лекциях, все знаю.
Ну хорошо. Я архитектор градостроительный, я работаю очень давно с ландшафтной архитектурой.
Вас я тоже знаю.
Ну хорошо, тогда все очень просто. Мы просто решили соединить как бы силы наши вместе. И когда Эдуард показал этот свой последний проект этого небоскреба, мы подумали, может быть, поработать скорее с экологией, с более как бы с территорией большего масштаба, нежели чем просто с планом зданий. Вот, и, собственно, посмотреть, что получится. So yeah, that's kind of the summary. I don't know, Ed, I can show a little bit of my work, but I'm just worried that we are running out of time. I don't know, just really quickly and briefly, as I think I will try to fit in 10 minutes or something. Share. If I'll do full screen, is that sharing full screen? No? Видно весь экран?
No.
Нет? Okay, let's just stick to this. I would never get around Zoom, so that's fine. Just let me.
You can share the new window of full screen window.
Full. But I need to stop sharing first.
Stop sharing and start sharing by.
Then I need to do the full screen, and then I need to share again. Okay, 1 second. Skip. Oops, view full screen. no, that was full screen, and that should be
presentation.
presentation.
You can show, yes.
So confusing.
Yes.
Okay, yeah. Can you see my screen or not?
Yes.
Видно экран?
Yes.
Ah, понятно. Okay, so as I said, I'm an architect and app designer. I'm based in London, but I'm doing research in Russia and in UK, and also involved in teaching landscape architecture and architecture in Architectural Association in Bartlett. So, and some time ago, I did a master course in Architectural Association, which is called Landscape Urbanism, where I have been introduced to kind of ecological thinking and process-oriented design experiments, where designers, instead of trying to design an image of the natural landscape, they moved into designing like mechanisms and behaviors of the natural landscapes. And that obviously involves application of computation and digital tools, which allows kind of simulation of such a complex behavior. And in particular, I'm interested in these kind of time-based platforms for representing change and evolution of natural processes we observe in these cities. And I'm looking for this kind of instruments allowing us to model dynamically changing interrelationships between natural and artificial actors of urban ecology. So very quickly, Елизавета, я уже представилась, я просто расскажу, что я закончила курс ландшафтного урбанизма в архитектурной ассоциации, где я, собственно, познакомилась с экологическим мышлением и процессоориентированными исследованиями, когда мы, собственно, мы дизайнеры, вместо создания изображения природы, как бы копии природы, мы переходим, собственно, к разработке и работе с механизмами поведения природных ландшафтов. И мы как бы проектируем сам механизм поведения природы, нежели просто картинка. И, естественно, это предполагает применение компьютерных технологий для того, чтобы стимулировать, имитировать, как бы визуализировать сценарии развития этих, собственно, этих территорий и попытаться, собственно, исследовать эти механизмы, которые стоят за естественными процессами в экологии и в городах. И мне особенно интересно именно приложение этой идеологии в городской среде, где, собственно, встречаются вот эти искусственные процессы, совмещенные с естественными процессами, их взаимоотношения. And very quickly, I'll just show a few projects, some of the workshops we did, and some of the research I've done, just to kind of to illustrate these tools and what do I mean when I say kind of urban dynamics. So of course there is some clear dynamics which been showed, like illustrated before. These are projects from students from landscape urbanism, and it's about floods, it's about erosion, and etc. It's a very, very physical processes. But also when you deal with cities, you move into the very volatile, very kind of virtual processes. There's interrelationships between different initiatives, different activities, different programs, and kind of within any urban strategy, there is certain interrelationship, but at some point they all become kind of physical in a way. So that was the point of the interest. And this is the workshop we did with smart geometry, and that was some sort of imitation of kind of emergence of bottom-up initiative in the creative economy in Brick Lane, London, and where we set up some sort of strategy. Well, we set up the site, we set up the strategy of certain logic of how do you move on, certain logic of interrelationships between different actors, between different stakeholders, and then we kind of gave different speeds, different interdependencies, and based on this kind of tool provided to us, we tried to do some sort of this scenarios of urban growth and evolution of some sort of different programs and different kind of influence of different programs amongst each other. So, so the first project was about this kind of emergence and bottom-up processes, and I know that architects are really interested in particular in that, but in my practice I actually faced that lots of us, a lot of the cities, they're actually lacking those bottom-up processes, all this emergence, which we can kind of, we're looking after this kind of agencies which driving cities. They sometimes never exist in the territory. Some of the cities and some of the areas, they actually really kind of really controlled and really, how do you say, very kind of inactive. So so this is yeah, as I said, very often urban environment is missing those bottom-up drivers. So this was another workshop which we did together with Edward and with the help of Rob Stewart-Smith. I don't know if you know him. He does amazing, amazing stuff now in States with his work. So, so this was a workshop, and here we were working with so-called kind of secret research Russian science centers. And those cities, as I said, constitute like very isolated, passive context, built and driven by state government projects. So it's and here we were trying to understand how we can create these bottom-up processes and to make these cities a little bit more self-sustainable. So there's a lot of exploration in terms of different strategies, and these are kind of our attempt to, on the basis of agent-based system and kind of lots of strategic rules we set up, trying to visualize the behavior of all these initiatives and how they can spatially distribute in the city. So this example was about the education initiatives. This one we did regarding green, let's say some sort of ecological initiatives in the city and green infrastructure and bringing a little bit of sustainable infrastructure to the city. And we were looking for some sort of local context which can actually help and kind of get connected to all these new projects and transform it, bring it to the next level. So, and this one was our attempt to visualize shared economy and small business. Also, it's quite an interesting, I'm not going to go deep into this stuff, but it was quite interesting, different types of collaborations, different types of initiatives, different types of small businesses, which we were trying to combine and create something bigger, like something that creates kind of a little bit more sustainable structure in the city. But I guess these two previous projects are a little bit too abstract, and obviously being like working with natural ecology, you need to really understand kind of the physicality, the physical part of the landscape. So so previous dynamics I showed, it's kind of some sort of modeling simulation and kind of it's very I would say speculative in a way. But here when we did a project together with Dark Ecology and we faced kind of the real dynamic, the material dynamic. We dealt with the landscape which is kind of disappearing, and the new landscape, new kind of dark landscape, which reappearing in this city, in this kind of mining city beyond Arctic Circle. So this is the project. It's kind of fieldwork project which we did for Dark Ecology together with Tatiana Grabachevskaya, and Just to explain dark ecology, it's a series of conference and cultural events beyond the Arctic Circle between Norway and Russia. And it became a kind of a meeting platform for artists, musicians, anthropologists, curators, and well-known philosophers like Timothy Morton and Graham Hyman. And so our research, we called it nickel materiality, and it explores kind of this industrial mining city, which ironically called nickel. Nickel is what they basically developed there. And that's the name of the town as well. So we looked into these cities through the lens of kind of material substances and textures and artifacts that emerged during city existence. And we created this catalog of almost 200 different materials and different artifacts we found in the city. And through this catalog, we kind of presented nickel, the city, as a material system. And we actually was quite excited about the fact that we managed to show it as a kind of multi-scalar entity, because by looking into like microscopic qualities of a particular materials of some sort of bioproducts which generated by the industry, we can actually tell the whole story of the bigger ecology and etc. So we created this online platform which is called Nickel Materiality, and we created this library of the different artifacts, and also included a series of maps where you can actually see the story of each material in each layer. And I guess regarding our workshop, that will be always something to keep in mind, that once you're dealing with some sort of satellite, large scale maps, and you always have this kind of zoomed out perception of some sort of process which is happening in a landscape, then you have to always know that it exists like it exists through all sorts of scales and ends up on this kind of very small microscopic scale. So we cannot really also working with data visualization, we should not forget about how close you have to zoom in order to really understand the process. That's pretty much it. I just would like to end in my favorite quote. Hopefully that will be helpful to understand the spirit of the workshop as well. It's like if we want to model some sort of dynamic life system, and this is a famous biologist, Gerald Edelman. He listed up that, of course, you need to simulate the organ of the animal, then you have to simulate the world or environment of that animal, then you have to simulate the interrelationships and interactions of that organ in the natural world. And then the fourth point, which is very important, is see what happens. So that's what we're going to do. We're going to kind of play with our tool and see what happens. That's pretty much it. And Елизавета, просто очень быстренько по проектам. Не знаю, если ты видела какие-то уже наши презентации. Первый проект, который я показала, это мы занимались, собственно, исследованием на Бриклейне локальных инициатив, вот этого, как это называется, творческого кластера. И, собственно, мы использовали инструмент, который был, собственно, сделан для моделирования программного распределения программ внутри здания. Но мы пошли дальше и прописали довольно сложные механизмы взаимоотношений между различными актерами, активистами на территории. Вот. И, собственно, попробовали промоделировать, как определенные инициативы будут развиваться во времени и пространстве. Еще один проект, который я показала, это был проект работы с закрытыми городами. И с закрытыми городами как бы мы всегда работаем с такими инициативами снизу, да, для того, чтобы найти выстроить какую-то устойчивую базу для городского развития. Но, в принципе, есть очень много городов, и закрытые города такое яркое проявление, которые управляются исключительно сверху, где инициатив очень мало, где очень мало какого-то внутреннего развития. И, собственно, вот этот воркшоп, который мы сделали на Стрелке вместе с Эдуардом, в том числе, мы, собственно, занимались как раз вот этими попыткой понять взаимодействие открытой системы и закрытой системы, каких-то инициатив, которые сами возникают, скажем так, controlled emergence, то есть это контролируемое саморазвитие, и, собственно, рамок, которые выстроены существующим контекстом закрытой системы. Вот предыдущие это были несколько разных типов инициатив, включая образовательные, как бы экологические проекты и такой shared economy с малый бизнес. А этот проект, это проект, который мы сделали с Татьяной Горбачевской в Арктике, на границе Норвегии и России, есть город Никель, в котором, собственно, вырабатывают никель. Совершенно экология этого города, совершенно, экология вообще этой территории была как бы довольно сильно подвергнута таким очень негативному влиянию этой индустрии, но при этом нас заинтересовал вот этот спектр довольно интересных материалов, которые мы нашли в этом городе. Использование вот этих биопродуктов, как сказать, продуктов переработки индустрии, типа шлак и так далее. В советское время он использовался в строительстве домов и так далее. И вообще этот город... Просто рассматривая все эти материалы и создавая, собственно, эту галерею этих артефактов, мы попытались объяснить и понять вообще все вот эти как бы процессы трансформации, которые происходили и будут происходить в этом городе, взаимодействие экологии, вот этих вот токсичных материалов вместе. Собственно, это было наше исследование. Я показала этот проект для того, чтобы просто привлечь внимание к тому, что мы очень часто работаем с как бы вот эти даты, визуализация данных и так далее в этих графиках прекрасных. Они всегда каким-то образом удалена от нас. То есть мы очень сложно добиться вот какого-то, найти такой инструмент, который позволяет нам как бы посмотреть через несколько масштабов, собственно, явления. И вот этот пример – это как раз когда какой-то процесс, который происходит на микроскопическом уровне с материалом, он оказывает влияние на, как бы, на макроуровне целой территории, целой ландшафтной территории. Вот. И, собственно, да, собственно, мы открыты к экспериментам. Вот так. Okay, guys, I hope I was fairly quick. So we are, I don't know, we are happy to start unless you have any questions. Edik, I think there is no,
Yes,
there is no questions, I guess, so we can just crack on.
Okay, maybe we can go through the our pipeline, and we'll start to see how the Google Earth Engine works. I share my screen. I hope all of you sign up to the Google Earth Engine. You can give me some feedback. Is your sign up? I just see the Laura. Yes.
Anyone else? Maybe maybe it will be easy if someone didn't sign up. Just raise your hand, yes, so we know. Just let us know. Can see. Okay. I haven't, but I will.
Okay. Maybe if you someone didn't say sign up, please do this, because it's our first big tool which we use as a tool for creating our dataset. Map datasets, and I just briefly show that what is about, and maybe after me Kat show some places, interesting places, and how it's so and show the dynamic of these places, okay. Google Earth Engine, it's initiative of the Google, which combine a lot of data from the satellites, different satellites. And what is interesting that it's absolutely free to use, and it's amazing, really amazing tool. Actually, I don't used it before, and I started several weeks ago to see these tools, and actually, and maybe it's I think it's very important to understand that current tools in which we can use for your work, for architecture, or maybe for art. You can explore during the several hours or several weeks, and I know don't and if I and I'm not a professional of the Google Earth Engine, but I show you how we can use several tools inside the Google Earth Engine which help us to download the the dataset. And but actually we don't use just only the Google Search Engine. We will use other tools from Google. It's Google Collaboratory. It's special special server for which allow you to run the code inside inside the cloud, and it's allow you to create some and reuse some code which was created by someone else, and we will use it for download the Google Earth Engine some data sets. Actually, of course, it's not to understand. To understand, I don't create this code by myself. I just Google it or just asked from my friends or something like this, and I explore it and understood how it's work, and how we can use it for our process. And if you go to the Google Search Engine, this is a website, and we can go to the data catalog, and there's a lot of a lot of data which we can use for our for our necessaries. And for example, we can go to some data sets. I just see. I just show you how this look like. For example, this is one of the data sets, one of the satellite data sets, and how it's structured. You can see the name of the data, and for what's very important for us, it's time for the data. It's a range of the dates when the satellite was doing its work and on stop. And for us, what's interesting is the data like this one, when we see the when you and we see that it's a good range from the 2002 to 2021, and very important for us, it's this kind of things. It's this is a name inside the database of the Google. This a real name, and what need and you can see the description of the dataset, and very important is the bands. Bands, it's actually each satellite captures the some data through the some we can say the some lenses. I mean that each satellite has several data sets actually. So it's like layers of the data, and you can see that this kind of satellite make six bands, six layers, data layers, and actually we can use each of them. And for example, we can see that we have the data set FPR, 50 meters, 500 meters, and we have a description to understand how it's what is exactly fraction of photosynthetically active radiation. It's and we can understand that it's about the how we understand the meaning of the data, that we can understood we can understand the how greeny is particular place, and of course we can see other stuff and other bands, and we can use other bands. And what we can do else with this data set, we can go to we can click to this icon and go to the code editor. It's a very not very hard tool to visualize the data. Actually, when you go with the link, Google automatically put the special code in this window, and you can just run this, and you can see the map of the data for this data. How can be predictable that Amazonia has a more greeny color, and this color actually this color related to the these colors in the palette, and you can actually see that you don't have just you can see that you see in the code this name in the data, the range, and the min and max, which you use to you can use for the interpolation of the data, and so of course it's very important. And how you can see that you see the two maps with two bands. It's first lay 500 meters and FPR 500 meters. And how you can see this this one and this one band. And on the map you can see the different layers. It's show us data layers. Of course, you can actually copy and paste this data, and you can put other band, maybe this one, and just run again, and see that you have not two but three layer, and of course you need to rename the for the legend of the map, and it's very it can look like something codey and difficult to understand who are not to work with the code, but how you can see is made very clear and understandable for me. I don't coder, and of course for me it's code. It's usually hardly I like more not visual languages, but if you can see, you can make something very understandable for you, and maybe you can change the color, and it will be our base instrument to work with the database from the Google Earth Engine. And I changed the color, and you can see you can switch between the layers and see the white black map. It just for initial understanding how it's work, and of course we can during this day I show you how you can work and how you can find your data to your data set. But actually maybe Katya can show some examples. Может быть, я повторю быстренько для этого, что, в общем-то, я показал, как работает Google Earth Engine, и что здесь у нее есть, если зайдете, вы увидите, что здесь есть каталог. Вы можете сами искать те данные, которые вам интересны, особенно вы, заходя на любую страницу, вы можете увидеть такую страничку с каждого датасета. И здесь важно само название. Важно очень, собственно, то, что показано, какой диапазон данных, в каком диапазоне времени работал
съемка происходила.
Да. Вот. И что для нас важно, что вот это вот имя будет нас часто встречаться, потому что это имя внутри баз данных Гугла, как бы, то есть вот там нам не само имя вот это надо будет, а вот именно вот эта вот часть. И что здесь есть всегда description, есть еще вот то, что band, это, то есть это слои, каждый сателлит, он снимает, каждый спутник снимает несколько типов данных, и вот вы можете посмотреть на каждый тип данных. То есть это название датасета, а внутри него еще есть слои. И для того, чтобы легко это визуализировать, вы переходите, можете просто перейти вот по этой иконке, кликнув, перейти в код-эдитор, и он по умолчанию сразу заполняется кодом, который позволит вам, просто нажав на Run, визуализировать данные. Причем он там по умолчанию может быть несколько давать бендов, вот этих вот слоев данных, и вы можете, например, здесь менять их. Также вы можете добавить свой, в смысле, вот так просто можно добавить, скопипастить, сделать копию и переименовать, и показать, отфильтровать, или, в общем, поработать здесь, он, в принципе, довольно-таки понятно, можно разобраться, там поменять, например, цвета вы можете сами себе, вот. Естественно, я в дальнейшем покажу, как это сделать, как вы с этим работать по уже конкретно для нашего дела. Вот. Ну, просто сейчас мы говорим, что Катя нам покажет еще некие примеры того, как вообще, какая динамика может быть в разных местах, и как потом, соответственно, мы будем эту динамику пытаться найти внутри уже этих сателлитных снимков.
Okay, so shall I share my screen? Мне расширить экран, да?
Да.
Share screen. You cannot. Can I share screen now? Okay, so basically one thing we discovered with kind of satellite imagery, as I said, certain processes which are very apparent, let's say in like in the landscape, not always easy to pick up on satellite images. Like, for example, I don't know, polluted territories like air pollution or soil pollution and etc. It's very difficult to grasp through satellites. So we were trying to focus, because we're currently limited to satellite imagery, we were trying to focus on those kind of dynamic evolution of the territory, which is very apparent, which is very clearly, especially for the purpose of this exercise. Just we kind of divided it into, let's say, into two types. One is kind of urban growth and expansion of cities into the landscape, and another process is kind of transformation of the landscape and deterioration of the landscape, and disappearance of the landscape. So this one is a very impressive urban growth in Pear River Delta in China. I don't know, probably have you guys who are familiar with that area, and because of it's located in China next to Hong Kong, and because of a certain policies and a special economic zone which has been created by China on the border with Hong Kong in 90s, the small fishing village expanded, and the whole territory, you can see it used to be agriculture land. It's all been industrialized and urbanized in literally 20 years. And out of the little fishing villages grew gigantic cities with million people, with millions, population of millions people. So, and it's quite clear to see all these growth. So all these kind of gray areas. This is industry and settlements which grew literally in 20 years. And this is in a way was example of some sort of very organic growth of city, because it was really kind of related to the existing territory, to the existing ownership on the territory, because it's basically transformation of agricultural land and agriculture field and existing old farms and villages into the urban and industrial sprawl. So even looking at this kind of into this dynamic, it looks very organic in the way. So that is one example which could be interesting to explore. Another example is obviously a very kind of simple example of Dubai, and you can look into Dubai, and at the same time you can look into Doha or Lusail in Qatar. I would say that it's kind of it's this urban sprawl and urban growth which has been driven by investment into the property development. And it also is an expansion into the sea, and it's kind of this reclaimed land which has been built on water. And I think I would say this is partially organic, but it's quite grid-based, and this is based on kind of some sort of spaces between infrastructure, the size of the how do you say, urban block, and the distances between biggest highways and etc. So it has certain rules about, like, let's say, top-down rules, but at the same time, because it's reclaimed land, it's quite responsive to the topography of the edge of the coastline and etc. Although it has this very abstract shapes like palm tree and earth and etc. So I would say it's quite an interesting place to explore our urban growth, because it's both. It has some sort of decision of the architect, but it's also based on some sort of natural properties of the landscape and a coastline. And I thought that maybe, yeah, this is the example of Qatar, which is fairly similar. You can see this beautiful harbor, which is kind of taking shapes and being occupied by the city. And the very, very, I would say the most abstract growth, I would say, and very, very mechanical growth in the way, is this growth in Las Vegas, when the whole city expanded, well, due to this kind of economical success of this space, which has basically never been naturally evolved city. It's just kind of some sort of decision which has been made to have this place there. And you can see that it has a very simple rules in a way of this grid which expands outwards. So we thought that maybe this one is quite an interesting example in terms of for neural networks kind of understand fairly simple principles of urban growth. So this is about kind of these urban growth and city expansion dynamics. Another example of when we move into the kind of deterioration of the territory, one great example is glaciers in Alaska, and obviously their disappearance is dictated by the global warming and etc. So that could be an interesting side to explore. This is Aral Sea. This is kind of which almost disappeared, or like we can say disappeared, or you cannot say disappearing because it's almost disappeared. And this used to be a fourth largest lake on Earth, and Soviet Union at some point made a like very brutal decision for sake of irrigation of the territories adjacent to, in Kazakhstan, Uzbekistan, whereas they were really pushing to create cotton, kind of expand the cotton growth in the areas. So for the sake of irrigating those areas, they kind of reverted rivers, and they kind of cut the supply, the water supply of these of Aral Sea. And due to kind of they created, they started this irreversible process of drying out of this lake. And I don't know if anyone came across this story. It's quite interesting, because basically it created the fact that it's dried out, and the salt which accumulated at the bottom of this big sea, and the toxins from the agricultural, how do you say, the pesticides which has been used in agriculture, and which eventually was kind of accumulating at the bottom of the sea, now became, once it dried and the bottom of the sea got exposed, created this very unhealthy, polluted kind of environment. But we thought that this example in terms of satellite studies quite interesting, just to understand this dynamic of drying of the body of water. So that that could be it. And another example, which is kind of very clear in the way, kind of similarly to, let's say, Las Vegas growth, this is the kind of deforestation process in Brazil, in our Amazonia area. So, and there are several drivers of this process, and the main reason is actually cattle ranching, and kind of cutting out these kind of rainforest in order to allow this kind of cattle ranching to happen. Because beef cattle became one of the main sources, like one of the biggest economic drivers of the territory. So, and including to, in addition to that, it was obviously logging and soybean production and mining. All these kind of economies, they are destroying Amazon forest. So, and you can obviously see how it's happening in the on the satellite maps. I guess we went through, I hope I didn't forget. Yeah, so these are the examples of those kind of locations which we thought could be interesting to explore, and where all these kind of dynamic processes we were talking about is very clearly visualized in satellites. So that's it. Елизавета, очень быстро переведу. Мы хотели посмотреть на, как бы для основы нашего воркшопа, конечно, не любой такой активный процесс на территории, на естественной территории или городской территории можно увидеть на вот этих снимках Гугла. И поэтому мы подобрали такие процессы, которые, в принципе, ну, для того, чтобы облегчить нам работу и наши упражнения, мы подобрали такие очень явные процессы, которые видно очень хорошо на этих снимках. И мы как бы разбили на два варианта. Один вариант — это, собственно, расползание города, расползание городов. Собственно, одну локацию – это долина Жемчужной реки, которая находится недалеко от Шэньчжэня и Гонконга. Это особенная экономическая зона, созданная в Китае, собственно, которая запустила такой совершенно необратимый процесс индустриализации и урбанизации, где, собственно, бывшие такие агрокультурные поля были за 20 лет превращены просто в бесконечные поля, занятые фабриками и, собственно, городской тканью. И так как это, собственно, находится на такой, находилось на основе довольно органического вот этого какого-то ландшафта, да, то есть это произошло замещение, какое-то естественное замещение одной территории другой территории. Это, в принципе, выглядит как очень, такое очень естественное, имеет какую-то естественную форму. И дальше следующий вариант это был либо Дубай, либо Доха в Катаре. Это как это, собственно, происходит вот это намывные территории и как бы экспансия вот этих новых городов. В принципе, мне кажется, это что-то как раз что-то среднее, потому что это частично работает с вот этой естественной границей воды, но при этом, естественно, имеет какие-то свои архитектурные правила определенные, которые как бы противоречат естественной как бы условиям территории. Ну и самый экстремальный вариант это мы предложили Лас-Вегас, когда просто вот эта система сетки улиц, она распространяется с дикой скоростью. Город растет и как-то и не останавливается пока. Вот. Что касается естественных процессов, как бы в таких в природных территориях, как бы за городскими территориями. Один вариант это был как раз вот это Амазония и то, что происходит с как бы вот это потеря rainforest, как по-русски. Ну, я думаю, ты поняла. Лес в Амазонии и Бразилии, который связан, собственно, с местной экономикой, когда вырубается лес для того, чтобы там разбивались ранчо, потому что, собственно, основной бизнес это как раз вот это развод скота. То есть это является основным драйвером, плюс там дополнительные как раз развитие агрокультуры, что там было еще, ну, вырубка леса сама в том числе. Про Аральское море, наверное, ты знаешь больше даже, чем я. В принципе, мы подумали, что это тоже довольно интересный как бы естественный процесс, который происходит. Было бы интересно посмотреть на вот эту динамику убывания на карте. Ну и довольно тоже яркая иллюстрация изменения климата. Это, собственно, исчезновение glacier, в Аляске. Эдуард, если напомнишь, как glacier по-русски, я забыла.
Ледник.
Ледник, да, исчезновение ледников. Да, исчезновение ледников в Аляске. So that's all our examples just listed now. So I can stop sharing. Guys, any questions so far? No questions. Okay, good. So we can just proceed, I guess.
Mm-hmm. I would like to say that to collaborate, I made a folder, a Google folder, to combine all of information. And actually, before our before our workshop, I shared with you to the emails which you give us, and actually, if someone have problem with have access to the folder, please ask us about this. But what you can see there, you can see the just brief. That's important. Most of the important is this is the Google Doc. And it shows our schedule. This is it's this file named infobox data sculpture, and I'm adding some link here, which will can help you to understand what tool we use, and I will add other links which when we go through the new tools. I put 3 links now, and this is a code editor which I shown you as, and this is how and this is the paper how it works, and maybe you can if you click here and open this doc, you can see the interface, how structure the interface, and what you can do and what happened here, and in each block of the interface, and you can understand what's happened in the code editor by itself. I have to say that code editor works with the JavaScript, but when we will use Google Colab, it's work with the Python, and it's a little bit different languages, but you can but actually most of the it's very similar, and you can see the when you can see the examples of the code in Google Editor, but actually when you go to the references, it's show the how all of functions in the library Earth Engine or Earth Engine. You can see the a lot of things will show you the function like this, which we will use for our preppers, like export image from the data sets, and it's have one name for the for the JavaScript and Python. And you can just see the properties of these functions. But maybe we don't get to this one so deeply, because actually I'll show you how we can use the Google Colab, this Google Colab, and it's not so hardly. But what I can say, where you can find this Google Colab file, you can go to the to our workshop folder and go to Colab notebooks, and you can see the this Google Earth Engine digital future Google Colab file, and but you don't, please don't use this and don't change this code. Please copy to your Google Drive this file and change and you use it for you, because if you change something inside this collab, it's changed for anyone, and if some broke the code, it will be not. I think no one would like this, actually you can do this now. If I can share, if you don't have the access now to the Google Drive, I can share to our chat this file, and put into our chat in the Zoom. I shared in our chat the link to Google Colab, and please when you go and when you open this file, you can select the file. Sorry for that, is not English, but it's system language, and you can find the save copy to your drive. Please do this and open the new your Google Colab file, and it's work for anyone independently. You can make this already.
Yeah, I think. But which drive is saving? Is that saving in our Google Drives? Это у нас сохраняется на нашем Google драйве.
Yes. You need to save this file to your Google Drive independently from our workshop folder.
Mm-hmm. Did anyone manage to save on your own Google Drive?
Да, представьте, что я показал, что у нас есть расшарил папочку, я надеюсь, если она расшарилась Елизаветой.
Да, я уже сделала копию этого.
Все хорошо, да?
Да, спасибо.
Okay, if all of you make this, make your own copy, go through this Google Colab file, and how does it work? You can see the interface of Google Colab. It's a new tool. We will have a lot of new tools, I think, during this workshop. But it's a simple tool. You can see the interface where you have blocks with a text or code. And if it's a code, you can see the icon with play icon, which if you click on this one, it's run the code inside this block. It's very important. It's each block run independently from other. But actually, what is important also that you need to run each block step by step. And for example, when you link, I just a moment, I restart my Google Colab to make it initial state.
What is the name of the tool in English? That will be.
Just for me, it's I just run again from initial state this file. And you can see that you have just this place, and you can run first one, and when it's running, you see the link which you need to open, and say which Google account you use for the sign up to the Google Earth Engine, and click allow, and after that show this code we need to copy by clicking on the icon, and put this code inside this box. Enter verification code. Control V and enter. After that, this run is finished, and it shows that successfully saved authorization token. It means that this Google Colab joined to the Google Earth Engine account.
Did anyone having problems with that? No, all good.
Okay. After that, we can we need to go through all of code blocks, and just run each other. Run, and how you can see that if you run something, you show the number in this place. It's a number. It's a number of the step which we for running of the code. And if you run something, this empty space will be numbered. Again. It just it's each box. It's run some code for to make some functions or save something, or initialize some libraries and so on. And actually, most of the codes have a comments which is have a green color and hash, and it's a comment to the for code, and we can if you would like to, you can go through this, through the code and see all of comments and try to understand what's happened in each block. And each block, in many blocks, has some names, two additional, understanding what happened. And as you can see, after the 6, I need to next one, next one, and I would like to stop on this part of the code, which named available layers. This is an important part of the code because it keep information about your layers, which we can use for our for the loading. Of course, you actually it's just several. It's just this list has just about 20 layers, 20 satellites, but actually you can, and of course you can you can set up and put here the new information about layers what you would like to have, but this is the initial layers, and it's and a little bit harder to put the information inside here, but actually each layer has this kind of text which inform about the properties of this layer, and for example, each layer has a name. This name is inside our code, and so satellite information is a name of the layer inside the Google database, and the information about which band we use. For example, many layers has a band, just one band, and it means that this layer has one will be colored by one channel. I mean, like it will be grayscale images. Actually, we need grayscale images because we need to create after this, when we download all of this, all of kind of the information, we need to download these images, grayscale images, and after that put to the model of neural network, and after that its neural network should generate new images, and they should be grayscale too, because we need to grayscale as a source for the monolith plugin, which convert these images into the volume, and it converts through the density of the color. White color will convert to the volume, and black color not converted. And because of this, we need it's more it's much easy to work with grayscale images by initial. And for this, I actually all of in this code have the for this code had different color for each layer, but for our pupils, I changed for all palette to grayscale from 0 to black 000 to white FFFF hash color. And this is a structure which allows us to make some database inside the Google Colab, and you can see the each you can see the all layers which you can use, and I will show you how you can understand what exactly layer means. You can copy paste the satellite name like this one. First, and go to the Google Earth Engine website and Google it, and you can see the page, and open. You can open this. Sorry. Sorry, we don't need this one. You need to go to the data catalog, and inside of this, make a search. And you can see this kind of data we can from the list of the layers. And how you can see, this is the layers which can be which show the different kind of cover types. And inside the bands, we can see the bands which you can use for which you can use for your data layers. And how you can see, just close this tab. You can see this. You can see the band and LC type 1, and you can find this LC type 1 here in this page, and you understand that it's land cover type 1 and International Biosphere Program classification. And actually, how you can understand, you can just copy another bands and put inside here. And it means that you just select other band read the first one. Okay. And what's important? What else important is the min and max values. It's not always shown correctly. I mean that not all band have a min and max, but and sometimes you need to can you find the min and max by your hand, but actually it's important because you need to these values to correctly for correct interpolation between colors and values. And what's else important? This is a kind of stuff. It is single false. It means that some layers has just one image, and other layers has a collection of image. Collection of image, I mean, means that it has this layer have a range of time, and because satellite capture the images each day or each year, day of 1 day of the year or something like this. Actually, very important. Very important that actually I don't understand. I don't understood, and I didn't find the information about how understood. How understand how frequently captured satellite captured the information. I mean, it's each day or each week or each year, and sometimes it's through the just experiment you find that this data has just one image per year, or one image per day. But if you see the single false, you understand that it means that it animated the data layer, but some layers.
So it's more than one image there. That's what you're saying.
Yeah.
Okay.
And but some layers has a single true. It means that it's just one layer. It can be a very interesting layer, but just for one time.
So we're not interested in those layers which has single true, because obviously there is no multiple data and no multiple maps.
Yes. Yes.
Okay.
And actually, it's it can be helpful just highlight the single false and see the all layers which are inside this list of data layers. Елизавета, вам понятно, как бы, в смысле, что до этого было, что, вот, в смысле, что мы проходим через все блоки, нажимая на Run?
Да. Да, это было понятно.
Вот, хорошо, да. И то, что, в смысле, что у нас этот лист содержит вот эту вот часть кода, блок этот, он содержит информацию, собственно, о тех слоях данных, которые мы можем использовать в данном случае, касательно этого файла. Вот. И что для того, чтобы посмотреть, вот, собственно, вы можете копировать имя сателлита и найти его, посмотреть всю информацию по нему, насколько возможно. Вот. И что, когда у вас есть свойство у слоя single false, то значит, что у вас этот слой анимированный. И значит, у вас, что может быть, иметь диапазон несколько снимков за какое-то количество времени. И, соответственно, можете тоже посмотреть его, вот, собственно, в свойствах каждого слоя будет написано.
И еще, может быть, добавить, Эдуард, то, что вот мы находим каждый спутник и каждая спутниковая как бы серия съемок. Ты сказал, что если пойти на страничку самого спутника, там можно найти дополнительные слои, да, под слои, подгруппы снимков.
Их можно посмотреть, какой...
Их можно заместить, то есть можно скопировать, да, допустим, там у них вот в этом коде показана только первая группа снимков, а вот в этой библиотеке можно посмотреть другие группы снимков и подставить их, как бы, и посмотреть... посмотреть их.
Да, если там мин и макс значения другие, то надо будет, соответственно, поменять их
на соответствующие.
Да.
Okay.
Next step. Next step it's about a setup and select the layer which we will use for downloading.
Eduard, stupid question from me. Do we have to run next to these layers? Do we have to press run or not? Because we didn't run all of them.
Yes. So you need to run.
So we need to run it.
Yes. And after that, we need to run all of the blocks actually, step by step. And next block, it's about selecting of the data layer. I'll select by default FPAR. We can find this. We can choose another other ones. We can just click on the list and select the other layers. We can just find what is FPR by this trick, and to find this layer in the data catalog, and we can see that this is the how I saw shown this layer before. It's kind of layer about green territories. And when I would like to say, show that when you select something, you can see that you actually change the code a little bit and put the name inside the code, just tricky things inside the Google Club that has a list of the all layers, and you can through this interface select what you need and run this kind of. I just comment. If error selected if error. I forgot the run the available layers. Don't know that it was. Sure. All is fine. And next step is selecting the filtering of the data. So what time range we would like to see in our download, and it's very important part. It's a little bit magic, because actually first of all you need to select the data, the dates, start data and end date, and you can see the boundaries of the range in the information of the data. I mean, this kind of data has range from 2002 to 2021. But actually, for the testing, you don't need to make this was one first time, because sometimes the data layers can be the data images from this kind of small range can be so a lot that we don't need to so many images for testing. I mean, after that, actually, of course, for the good training of the model of the neural network, 1,000 images better than 100 images, of course. But for testing, we can find that is good data, good range of the good range of the data, good boundaries of the territory, and after this, we can you can change the time range and download all of the images. And I select 2008 and data as 2090. Other things is that you can see the filter by dates, and when you check this, you will use this kind of dates, and sometimes you don't need all of the images, but you can for this you can use other checkbox 1 day per year, and if you use this, you can just say what day of year you need. I mean, if I understand it, it's a number. It's a number inside the year, but actually not all of the layers can use this kind of checkbox. and by when I experiment with this, I found that you can use this for the this kind of layer, if Pear AR, and you can use just the filter by dates. Yes, and next one. Okay, you need to run this block after you select what you would like to, what your time range. Next one, run two. Next one, run. And what this block make? It's shown the interactive map with your data by and for to understand what and you can select the center of the center of the map. Your and map zoom. Map zoom is how you close to the region, some region. If you put a one, 2 or 1, it will be like a wall world. 10, it's about just a little bit closer.
How do we know the scale, the zoom
actually,
scale?
I just moment. Good question. In the, I think it's here, but it was here. I found, just a moment, I need to check out this. In some paper, I found the zoom classification. I mean, for which zoom, no, which zoom list of zoom and dimensions. Yes, this one.
Oh, that's good.
Yes, and if you would like to see the map with just how is zoom 10, it means that you see the pixel size 152.
So 1 pixel is 152 meters.
Yeah.
Oh wow, that's very small, right?
But if
no, actually that could be about right if we're looking into our.
But zoom, it's not about zoom of the data. I mean, it's not about that you have this precise scale for the data pixel. It's just about the map pixel.
Yeah, I understand.
Yeah, and if you would like to understand the resolution of the data, you can go to the information, and sometimes they show as here, you know, 500 meters or.
So 1 pixel is 500 meters, right?
Yeah, exactly for this the data layers. And here, it's yeah, resolution 500 meters too. Yeah. But sometimes it's 25 meters. Sometimes other one.
Is that a good moment to explain the locations that you have in your Excel? Is it something we're going to share? The links with the locations of our example sites? Because those are which you put in, right?
Yeah, actually, I have I made a spreadsheet, and it should be inside our folder, I guess. No, it's yeah. And it's inside the this folder, e-datasets, and I made the spreadsheet with a central of location, which which were shown by the Katya and Zoom for this. And you can actually go to the link which shown by Katya and see the displays and see the information.
If you want to move or adjust, obviously your location changes, so you will need to copy paste that latitude and longitude, right?
Yes, yes. It's lat and long. Sometimes they actually this very strange thing that sometimes they need to latitude and longitude. Sometimes in this order. Sometimes you need to ask different order, longitude, latitude. And sometimes it's very magic. But
it should be the same, right? It should be like literally latitude and longitude in the same order as in your code. So you just literally copy pasting it.
Yeah, in our code, it's this is like a latitude longitude, like here. Now I just copy paste the Amazonian coordinations and show this kind of place. And actually, this is an interactive map. You and after you run this code, and you can see the example of the image. I mean, example because actually we don't know exactly which kind of time in the data we show on the map. But it's help to understand that it's all right with the data. It's look good. It's what you're going to export from the Google Cloud. After this one, next blocks is about exporting the data. And first one shows that the bounding box of the map which you would like to export. For example, to this one, you can to make this one, you can go to the this website. For this, you can click Control plus click and go to the special website, which allow you to find the bounding box anywhere, and this generates the longitude and latitude. And we need to CSV because many standards you have, and CSV standard, and just Control C, Control V. And but actually, what's not so good that you couldn't find place by center, for example, and you need to find the place by your hand
manually. Yeah.
Just a moment, if you have, if I remember, this our place. which we would like to explore in Amazonia. It was this one. And I just Control C and Control V, but just but you need this house sign скобки квадратные.
Brackets. So so we need to have brackets there,
yes,
right? Yeah, of course. When we copy paste it, make sure you the brackets.
Inside the bracket. And run this. And what important things which we need to do is connect our Google Cloud with our Google Drive to export for exporting images from Collab inside your Google Drive. Now, for this we run this block, and it's already done for me. But when you run it, it shows like in the first one the code, the link which we need to go to the list. You need to go to this link and allow Google Cloud to join to Google Drive, and after this we need to copy the codes which will be shown to you, and copy and pass to the box, not here but here. Actually, this run should be done just one time, because after joining, we don't need to join again. Just one time. And after this, you can export the single image of the data. You can put here a scale of the data. Actually, we can just put here the huge number to match resolution for good resolution, like 20, 30. It's not so important.
Okay, so it don't have to be related to the scale we put before, right?
Yeah.
It's a different number.
It's related to the data scale, the data resolution.
Okay.
Because in some time, if you sometimes you if you have a resolution, for example, in scale 30, but you can export the data in scale 10. And it gets less resolution of the data, meaning that pixel will be bigger than in initial data. And for this, I suggest just make a scale like a 30, 40, because it's very it's very it's a good resolution, and it's for each pixel will be 30 resolutions, about a meter, 1 meter.
Okay, so we'll stick to 30. Good.
And select the target folder. Important here is that you can you couldn't make a folder inside the folder. It's like this one. Because this code don't understand the subfolders, and we need to folders in the root. Just this one. You don't need to create this one. It's if you don't have this folder with this name, it creates this folder. And file prefix, file name. my suggestion is to create a name related to the name of the satellite layer, like this one, FRAP, and bands of FPR 500 meters for this layer, and I run it, and it should. I can now I can go to the my export folder and try to find this kind of image. Actually, sometimes it's not happen because it's just a moment. No. You need to know that this code running not parallel, and it's running inside the Google Earth Engine. And after when Google Earth Engine creates this image, they sent it into the Google Drive folder. And sometimes it's goes some time. And we need to wait. You need to wait, and sometimes need a time.
So I don't know if anyone was following and doing in parallel. Did you manage to export your images in your files? Did
no, I still don't see my files on the folder.
Do you have any errors in your?
No.
No.
Sometimes that it happens. Actually, I know there are one things which can be taken. It's just this one. When you can go to your Google Earth Engine code editor and go to this window with the tasks, and it's an old task. Go through from Google Colab or from the Google editor by itself, and you can see in my case, it shows that this last task was not made. I don't know why, but sometimes it's happened. Maybe you can see I can see the information.
Yeah, I see there is like a little wheel turning, so I think it's still working on it.
It's things that it's showing me that is export too large for him or for Google Engine. So, maybe you need to this. Maybe you need to decrease the scale. Just see there, and I can see the information inside the. I don't see that my last task. It can be a little bit tricky to sometimes understand what's happening, but missed the tab. This one. all of these tasks. Previous task was not generated too. Okay, just go through the next one. It's because this one is about a single image. We can experiment with this, but next one next one block, it's about task status, and you can see the task. It shows that the state is failed. Okay, and here it shows me export error message, which I found in the which I found it here. I don't understand why it's too large. Okay, but go to the export all years and the images for the images for the it says many images, and we can just see that scale 2. It's 20. I tested and it works okay. Next one, it's a target folder. It can be you can copy paste target folder 2 here, and file prefix like this one. And when you can run this one, it makes a series of the tasks that which can show found here too. Just a moment. Yeah, it's shown. You can see a lot of tasks, and you can see that it's really many tasks they create. For each image, they create their own independent task. And you can go to the to your folder and see that how these images are creating, like this one. After this, this, you can you can download it to your phone, to your computer. It's up again to me. Yes, and it can take some time, and after several minutes, or maybe 10, 30 minutes, it will be saved to your Google Drive, and after that you can download it, and we can when you download it, we can prepare this data to training the model, but it will be in the next time, in the next day, and who create these steps and download the images.
Did anyone manage to download the images? Laura, are you still having problems with that?
No, well, I think I got a black rectangle, like it didn't load it stuff.
Black
but
rectangle? What kind of bounding box do you use? because sometimes you can, I have this problem too, but I understood that my rectangle was in the ocean, and because of this, I have a black data.
Okay. Okay, so I'll try running it again with a new bounding box.
Mm-hmm.
But yeah, for the first example, I just got like 1 megabyte image, and that's it. So I think it maybe was the bounding box that I didn't.
Yes. Because I have the same problem. I think it's about the bounding box.
Anyone else?
Елизавета, у вас получается пройти эти шаги, или что-то может быть непонятно, я могу объяснить.
Так, сейчас, секундочку. Ага. Все, я сейчас более-менее пока разобралась. Мне сначала выскакивала ошибка, а потом поняла, что нужно было зайти сначала в этот Google. Да. Сейчас мне вроде пока пошло.
Хорошо.
Угу, спасибо.
What about the rest of the guys? Anyone managed to download images or anything not clear? If you have any errors, just ask. Don't be shy. If you share your screen, we can look at it, or anyway, we're here to help.
Sorry, can I see quickly how which value from the bounding box you copy? Because I get two values.
You mean that
the bounding box, that was a bit confusing for me as well, Eddie, if you can just briefly.
I mean, when you go to this code, you can not this one. This one. You can find the big bounding box from this website.
Mm-hmm.
Control plus click, and you can see the maybe you don't see the no, sorry.
Oh, got it. Sorry, I had instead of CSV, I had a different value.
Yes, you need to see CSV standard, and it's like just how in the standard format of how you show the data about this bounding box. It's just 4 numbers, latitude, longitude, and for left top. Not important because actually you don't need you can remember you should remember that if you just copy from the CSV standard of this site, you and copy paste to this box. You can see it will be right standard, correct standard, and you will show this. And what need to if you choose some bounded box or select the another layers, you need to go through all code blocks after this selection. For example, if I select other layer like a NDWI, you need to run these codes and all codes after this code again.
Okay, after anything been modified, you have to run all the blocks which are following down.
Yeah, yeah.
Okay.
If you just change the bounding box, you need just run box after this after the code, this code block.
Mm-hmm.
And don't forget the right name, because if you download something with not correct name, it's for you will be not so clear what you exported.
Yeah, so make sure that the name is coordinated with the name of the layer you're looking at.
Okay.
Okay.
Actually, we go to end of this day, and actually, if you don't have if you don't have a question, we can
wrap up. I was just wondering, maybe we forgot to ask you guys introduce yourself, because it's a bit strange that we I guess it would be nice to know, like, where you based, and what is your interest, like what are you studying or what are you working, because I knew that it's not only architects who applied for our workshop, so it would be nice to just hear a few words from you. How do we do that? Shall we just name? Because it's some order. Okay, Елизавета, мы просто хотели, чтобы ребята представились немножко, чтобы мы знали, кто и где находится, и кто чем интересуется, кто чем занимается. So don't worry, you can speak Russian, I can translate. So that's shall we start from Елизавета? Давай с тебя начнем.
Хорошо. My name is Lisa. I'm from Russia. I'm an architect, designer, и additive manufacturing.
Nice.
Thank you.
Okay, nice to meet you. So let's move on to Laura.
Yeah, hi. I'm a Mexican new media artist, and I also work with music. And right now I'm studying for a PhD at the University of Washington on new media, experimental media. And yeah, I mean, I worked a bit with Google Colab, and I'm interested. I work a lot with VR and photogrammetry, and architecture is architecture and living spaces is one of the main topics of interest for my work. So that's why I was really interested in taking this workshop. And I worked a little bit with GAN and AI on Google Colab. So yeah.
Oh, that's fantastic. That's great. Thank you. And sorry, Nilüfer, I apologize. It's very international workshop, so I might mispronounce your name. So just introduce yourself, please.
Thank you. That was exact pronunciation. Thank you. Yes, I'm Nilüfer. I come from Iran, and I study the second year of Master of Sustainable Architecture in Norway, Norwegian University NTNU. And but currently in the summer I'm in Iran. And as Laura said, my interest is AI and the way, like especially AR and VR. So I'm really curious about how all these data that we're working on can help us and get like cool sculpture shapes and great results. Yeah.
Oh, fantastic. Great. Thanks. Okay. Ling Tan, are you there?
Yes, I'm here.
Hi.
Hello, everyone. My name is Ling Tian. You can call me Ling, and I'm from China. and I'm a graduate student in architecture at the University of Melbourne. And I'm a little interested in the data analyze. So yeah, that's it. Thank you.
Well, that's great. That's great. Olivia, are you with us? It's a bit hard to tell because you guys not turning the video on, but that's fine. I know sometimes it's especially.
I'm Olivia. I'm from China too. I studied architecture in University of Toronto in Canada. I just finished my third year, and now I'm doing like an intern for summer vacation. I'm also interested in architecture design and maybe data visualization, like AI, and how to create like um like model rendering images of data and like different ways of like representation. Yeah.
That's great. That's great. Okay, so we have Shuming Zhu. I'm sorry, I could be really wrong.
Yeah, can you hear me?
Yes, yes.
All right, so hello. I'm an architecture student currently studying in Melbourne in RMIT. Yeah, I'm just interested in the data transfer and the skyscraper. I think the skyscraper he showed is actually quite amazing, and yeah, I think that's it.
That's great. Okay.
Yeah.
And you built a great skyscraper. Well done. Together with AI. Well, we'll try to create something amazing. Very similar. Xiqian Huang.
Hi, I'm Chen Huang, and I'm in MIT too. And I'm really interested in style and cycle stuff and create the image. And I want to learn how to build 3D model from the picture. Yeah, that's how. Thank you.
Thanks. And Leon Cho, are you with us? Leon? Well, we kind of appreciate the time difference, guys. So some of them, if some of you left earlier, I understand some parts of the world must be like 2 o'clock in the morning, something crazy. Okay, there's a Ed, I'm a bit confused. There's also data sculpt workshop. Is that our kind of stream into YouTube, or is that some sort of participant? I'm not sure. Okay, anyone in the group I didn't name or didn't anyone who hasn't introduced themselves? No? Okay, I guess we all met. Fantastic. It's really nice to see you and really nice to hear the kind of response and your interest. Okay, I guess next, tomorrow we will crack on with AI. I would suggest to definitely try yourself to extract these data images. Obviously, we will share some sets tomorrow, so you can work with something in case you didn't succeed to do it on your own. But please give it a go. If something is unclear, email us. Yes, send us text. We'll try to help and support so it will go smoothly. And yeah, it will be nice to hear from you maybe tomorrow. If you can just say what would be the interesting location for you to explore. and which kind of dynamic process you'll be interested in, which we can grasp in our satellite imagery or somehow translate in our visualization. Okay. Ed, anything else? We are happy.
Yeah.
Yeah.
Yes, I just I would like to add that you can try to find several places, locations, and to explore the different data sets for each one, and you can around the export code, and for each location independently, and waiting for when all of these tasks will be done, and all of the images will be uploaded to your Google Drive. I think it's can be please don't waiting when all of the data will be uploaded. Just make several tasks and see the result.
Okay.
Can I have just a quick question about the data? Should we put it in different folders, or just how it is on the
Actually, it doesn't matter. It's when we actually when I started to download a lot of images, maybe better to make for each database own folder. Maybe it's help to don't miss something.
Okay, thank you.
Okay, good guys. So tomorrow, same place, same time, right? And Ed, you shared the links, so it should be, if you can add it to your calendar, you guys will get a reminder in the link. So we'll meet then. Okay, nice. Okay, good.
Thank you very much.
So,
thank you.
Thank you. So see you tomorrow.
Bye.
Bye-bye.
Bye.